Okay. Hey, I want to cover the loss function right here. So, if you're familiar with linear regression, the loss of a linear function, we're gonna use MSE, right? But what happens if we use MSE on logistic regression, right? What's gonna happen is we're gonna get a function. We're gonna get a non-convex function, right? So it might look something like this. Actually, that's terrible. So we might get something like this. So when we try to find the gradient, when we try to apply gradient descent of this function, and we go down and down and down and down, gradient is actually gonna stop right here, while this is only a local minimum, and this being our global minimum, which is what we're trying to find. So we can't actually apply MSE to logistic regression, so this is all bad. Actually, let me just open a new paint one. Okay, and basically, what would our loss for a single prediction? So the loss given a prediction. Okay, and actually, before I do that, so the entire idea is, given a set of x, given a set of x and y variables, we want to know the probability once probability of, or just once y hat, our prediction. Yeah, so y hat, our prediction, to approximately equal to the actual y value, right? So the loss of a single prediction along with its observed value, so y hat, obviously our prediction, and the observed value y is going to be negative y log, y being our observed value of y prediction being our predicted value, plus 1 minus y log of 1 minus y pred. So this is the loss of a single value, of a single prediction given its actual observed value. Now the cost function, if you don't know what a cost function is, again, you should really do research about these things. But the cost function is pretty much the sum of all the loss functions. So it's the sum, and actually 1 negative 1m is the sum of all of our, let me do this in black, the sum of all of our losses. So every single prediction and its observed value, the sum of all of that is going to be actually the cost. And actually, let me just say y is equal to 1 to make this a little better. These are superscripts, basically representing the ith iteration. So I may equal to like 3, meaning we are on our third predicted value comparing to our third observed value. And if you don't know summation notation, please again do research on that. And this should be M on top.